Hi guys, this video is about predicting products, and welcome to the Brady Bunch. Okay, first thing we want to do is we want to have our problems, and we do need our periodic table in front of us. What we want on the periodic table is going to be on the back, and on the back we have the right side. It's called the metal activity series, okay? So make sure you have these two things available. All right, so we have sodium oxide and potassium. Since it is single replacement, my single element is going to boot out either the sodium or the oxygen. Now, since potassium takes a positive charge, it's going to boot out the sodium. So I like to draw an arrow booting sodium out all alone, and then this leaves oxygen free to make a bond with potassium. Potassium takes a positive 1 charge. Oxygen is a negative 2. So it takes 2 potassiums to cancel out that oxygen, and then I erase, or in this case, scribble out all the charges so that I know I have a neutral molecule, okay? So here is zinc. I have an element all alone. It's single replacement. And so zinc takes a positive 2 charge. It's a tricky metal, so I do have to be told what charge it'll take. It's positive 2, so zinc is going to bump out lead. Now we do want to make sure that zinc is higher on the activity series than lead. So if we find lead here and zinc is higher, so zinc is stronger and can bump out lead. So lead does end up all alone. And now zinc with a positive 2, nitrate is a negative 1. Okay, takes 2 negative 1s to cancel out that zinc. And so we have our formula getting rid of all charges. Okay. Magnesium is going to take a positive charge and bump out the potassium. So we're going to take a look at our activity series. So we find magnesium, and is it higher on the list than potassium? It is not. Potassium is higher. So potassium is stronger. There will be no reaction here. All right, fluorine. Fluorine is negative, and it is not a metal. It will not be on the metal activity series. So fluorine is going to take a negative 1 charge, so it's going to bump out that chlorine. Chlorine is one of our diatomics, so it does get a 2. Sodium is a positive 1. Fluorine takes a negative 1. And so positive 1 and negative 1 cancel out. Let's draw a better one there. And then get rid of all charges. Okay, when I have words, I have to be able to translate that into symbols. So aluminum is just aluminum. Nickel has a positive 2 charge. Sulfate, I look up on my periodic table, on the back of the periodic table, and I find sulfate has a negative 2 charge. So positive 2 and negative 2 cancel each other out, so NiSO4. Aluminum and nickel, I do need to look at my metal activity series. Is aluminum higher? So here's aluminum, and there's nickel. So yes, aluminum is stronger. It will bump out the nickel. So nickel ends up all alone, and aluminum's a positive 3. Sulfate is a negative 2. So we get another negative 2 that we need. Now I have negative 4. So 3 is smaller, so I need another 3. Now I have positive 6, so I need another negative 2. Now I have negative 6. So it took 2 aluminums and 3 sulfates in order to cancel out and make that formula, and then I get rid of all the charges. All right. copper 2 hydroxide, and silver. So silver is Ag, copper is Cu plus 2, hydroxide is OH negative 1, so we need 2 of them. Now silver is going to try and bump out that copper. We're going to look at our metal activity series and find silver and copper. Copper is higher on the list, so copper is stronger. This is a no reaction. All right, guys, I hope that makes sense for single replacement reactions. Double replacement is coming up. Okay, guys, this is the lesson for double replacement where we are predicting the products. Now, the nice thing about this is double replacement is that I do not need my metal activity series, okay? It is assumed to occur. So here we go. My bromine and my oxygen are going to switch places. So my aluminum, that is a positive 3, is going to match up with my oxygen, that is a negative 2. My iron, I don't know the charge of my iron, except it's here in this molecule, so I have to figure out the charge. So Fe2O3, it takes 2 irons to cancel out 3 oxygens. That's actually what we just had here. Minus 2, minus 2, minus 2. So this has to be positive 3, positive 3. So iron is going to be positive 3. It's going to be matched up with bromine, which is a negative 1. So it takes 3 bromines to cancel out that iron. I should have not had a space here. And that is done. All right. Nitrate and chlorine are going to trade places here. So silver has a charge of positive 1, and it's going to be with chlorine now. Chlorine has a negative 1, so those cancel out, so AgCl. And now zinc, which I can tell has a positive 2 charge, and nitrate is a negative 1, so I'm going to need 2 of those nitrates to cancel out 1 zinc. All right. Now we have NaN and rubidium hydroxide, so sodium nitride. So nitride and hydroxide are going to change places. So my sodium, which is a positive 1, is going to be matched up with my hydroxide, which is a negative 1, so I just write NaOH. And then my rubidium, which I can find on the periodic table, is a positive 1. It's going to be matched up with nitrogen. Nitrogen is a negative 3, so it's going to take 3 rubidiums to cancel out that nitrogen. When I go from the names to the formulas, first I write down the symbol with the charge. Phosphide, so that is just phosphorus. Copper is a tricky metal, so the charge is right there. Carbonate, CO3, negative 2. So now I'm going to put them together. So I'm going to have lithium 3 phosphide and copper carbonate. And then what are they going to make? So they have to switch partners. So our phosphorus and our carbonate have to switch partners. So lithium, positive 1, is going to be matched up with carbonate, which is a negative 2. And copper, a positive 2, is going to be matched up with phosphide, a negative 3. All right, I'm going to do one more. Ammonium, NH4 plus 1, sulfide, so it's just sulfur off the periodic table. Barium, positive 2, and iodide is a negative 1. I know those, you just look on the periodic table to find them. So now writing it out as symbols. So ammonium, there's going to be 2 of them to cancel out that sulfur. And then barium is a positive 2, so there's going to be 2 iodines to cancel out that barium. And now we're going to change places. So sulfur and iodine are going to change places. So ammonium is a positive 1 and iodine is a negative 1. So ammonium iodide. And barium is a positive 2 and sulfur is a negative 2. So BAS, or barium sulfide. All right, any questions? I hope. You can email me if you have the ability to, or talk to one of your friends in class. So I hope that works for you. See you later. Bye.